Alright, so we're going to be graphing parabolas today, and we've actually graphed a couple in our reviews already, but parabolas are the graphs of quadratic functions. So a quadratic function in standard form is y equals ax squared plus bx plus c. So the main determining factor is that the highest exponent is squared. It may have an x to the first, and then there may be a constant. A cannot equal 0, because if a was equal to 0, then we would not have a squared term, and that would not be quadratic. If the a was 0, then this would be linear. That'd be a line. Well, that's good. Okay, the graph of things that are squared as the highest exponent are called parabolas, and they basically have a U-shape to them. Okay, parabolas open up if a is positive, or down if a is negative. That parallels the slope of a line. If the slope of a line is positive, it goes up. If it's negative, it goes down. So that's similar to slopes for lines. So sometimes we say stuff and maybe we should write it down to remember, although that's probably not that hard to remember. So here's some functions. Usually in lower level math classes we mostly just use y equals, but in higher level math classes we use function notation to say we have a function in terms of x. Basically these can be interchanged. That's why we have it this way here. So the first question, so we're asked two questions. Is it quadratic? And if it is quadratic, does it open up or down? So as we look at this first one, we're asking, could it fit into this form here? So there's an x squared, that's the highest power, and so yeah, that's quadratic. So yes. Alright, and then does that open up or down? So hopefully you can kind of answer these yourself. Pause and do that now. So that's positive, so this opens up. Okay. As we look at this next one here, there is no squared term. The highest power is just the first term, so that's no. And since it's no, we don't need to say whether it opens up or down. We could say it's linear. That doesn't really affect that. So the next one is that quadratic. So as we look across there, it has an x squared. So your initial thought might be yes, but there's an x cubed here. So that x cubed would be a problem. So that is also going to be a no. And that one is called cubic. Cubed. Okay. This next one, now when you look across there, you have to, it's not always in standard form, so you want to look around the whole thing and you see there is an x squared, that is the highest exponent, and so yes, that's quadratic. Now don't be distracted by this, the 5 is positive, but we're looking at in front of the x squared, and that is negative, so that means it opens down. Okay. Now as we look across here, our highest power is x is squared, so yes, that is a quadratic function. Now you want to be careful because this a value refers to when it's in standard form, which means y is by itself. So here y is not by itself. So we would need to modify this and actually subtract x squared from both sides like that, and now we can see that the a term is negative, so that's also going to be down. Alright. This is just the line spacing got off by 1, so that's supposed to be up on the previous page, so don't worry about that. Okay, so let's look at graphing a parabola here. So we'll do about red and green. So we're going to graph y1 of x squared is going to be the parent function. So I'm going to do that in green, and then y2 I'll do in red. So those numbers are usually a little bit lower, kind of like an exponent is up here. They're called subscripts, And what that allows us to do is we can have an infinite number of variables, because we can have y1, y2, y3, y4, y5, and we can go as long as we need to with that. So that's what that subscript means. So let's take a look at this. So let's just try some values here. Now usually there's some logic behind how we choose these numbers, so we'll talk about that maybe as we go here. So if we look at the difference between these numbers that I chose in this chart, this was went up 1, up 1, up 1, up 1. Now if we plug those in and see what happens here, negative 2 squared. Now we want to be careful here. This is negative 2 squared. So that means negative 2 times negative 2, which is 4. We don't want to mix that up. Negative x squared is not equal to negative x squared. This is negative. This is positive. This is negative x times negative x. This is negative 1 times x squared. So that's a common mistake we see even in higher level math classes, so you want to make sure you stay clear on that. And then here, negative 1 squared, negative 1 times negative 1 is positive 1, 0 times 0, and we get this here. Now, if we look, going from 4 to negative 1, that's negative 3. And then going from 1 to 0, that's negative 1. And then going from 0 to 1, that's 1. And then going from 1 to 4, that's 3. Okay, so this says find the second difference. That's the first difference, the difference between those numbers. But the second difference is the difference between those numbers. So from here to here, that's plus 2. And from here to here, negative 1 to positive 1, that's plus 2. And that's plus 2. Okay, so that was the first difference. And then this is the second difference. Okay, so if the second difference is constant, it's not changing like here, then what that means is that you have a quadratic equation, which we already knew because we were graphing a quadratic equation from the beginning. But that is something that helps us in patterns. If we see a pattern of numbers, we can look at those differences. Okay, now domain and range is something hopefully you've seen before. So domain refers to the x values and range refers to the y values. And those are in alphabetical order, so both the x and the y and the d and the r. So that should help you remember which is which. So the domain are what values of x are possible. Well, I could plug negative 1,000,000 in here and square that, no problem. I could plug in negative 5, I could plug in 0, I could plug in 20. There's really nothing that we can't plug in there. So what we do is we say that that can be negative infinity to positive infinity. Now, numbers don't stop at infinity, they keep going, but this just lets people know that it goes on forever, smaller numbers, and then forever bigger numbers. Now, the range is going to be a little bit different. Think about what's the lowest y value that we can get. Well, we can plug negative numbers in here, but those negative numbers get squared, so that's really going to become positive, so that's not helpful. So if you take it down, the lowest number that we could get, if we plug 0 in for x, we get 0 for y. So our lowest number that we can get is 0, and then our largest number we can get, we can just keep plugging numbers in there forever, so that approaches infinity. Now, if we actually get to the number, we use a bracket. It means that it includes that number. And if we do not reach that number, then we use a parenthesis. That's called interval notation. Interval notation. Okay. And we can graph that over here. So that was 0, 0, 1, 1. Now, there's a couple things happening here. One is that there's a pattern. The normal pattern is over 1, and up 1, and then over 1, up 3, 1, 3, 5, 7, So 1, 3, 1, 2, 3, 4, 5. And we could get there. We could plug in 3 and get 9. That's not a big deal. But so that's the first thing, is that the basic parent function, we call it the parent function because it's the original x squared. So follows that pattern. Now, also, parabolas have something called the line of symmetry. And the line of symmetry divides it down the middle and allows us to reflect points over the line of symmetry. Now that should be a dotted line because it's not actually part of the graph, it just helps us graph. And so anytime you get a point on one side of the line of symmetry, you can take it over the other side. So this is 2 to the right, so I can also go 2 to the left. This is 3 to the right, so we can also go 3 to the left. Okay? Now, when you graph this, try to keep the vertex curved. It's easy when you're graphing this to come down to both sides and come to a point, but really try to keep it, try to go in at an angle and then curve it through the vertex. The vertex is the turning point there. So that's not too bad, it's a little bit. Okay. So the vertex is the turning point. It'll also be the minimum or the maximum value. So you can see here that the vertex here is the minimum value. It's the lowest value that we have here. If the parabola is going down, then it's going to be the maximum. I already talked about the line of symmetry. Okay, so now let's look at this one. So let's use the same numbers. We'll talk about choosing other numbers sometimes, but let's use the same. So normally we pick x, and there's a reason sometimes why we pick certain numbers, because it makes it work out easier. So if we plug in -2 in there, -2 squared is 4, 4 plus 3 is 7. 4, 0, it's 3, and 4, and 7. So if we look here, that's going to be -3, -1, 1, 3. If we do that again, it should be already obvious, but that's going to be 2, 2. And it doesn't have to be 2 necessarily. It just has to be the same number if the second difference is the same number. Okay, so now we could plot those points. So 0, 3 is right here, and then over 1, up 1, over 1, up 3, and then we're off the graph here. So this one so you can see basically that the parent function, the green one, is just shifted up. Each of these points moved up 3. Now if you think about how far to the left and the right it goes, like x values, what can we plug in? Well, we can still plug in everything. So all real numbers. Okay? Or another way to write that is negative infinity less than x less than infinity, like that. Okay, so here the y values, now look, no matter what we plug in there, it's going to be squared, so it's going to be positive. So the smallest that can be is 0 if we plug in 0. So 0 plus 3 is 3. So the smallest number there, so y has to be greater than or equal to 3. Now we're just writing it a different way, so we could write those in this form as well. So that's some of the basics for graphing parabolas. Obviously you had Algebra 1, so you should have some of that down already. Use a graphing calculator to compare the graphs. So I don't want to do that time-wise, but what would happen if you do have a graphing calculator, you could try it, or you can go on your computer and type, there's some free graphing calculators you could use. But what you're going to find out is that all 4 of those have the same axis of symmetry. Something like this. Okay? So they kind of follow that same pattern as this does. So what does that show you? What's a conclusion you can make based on that? Alright. Well, the only thing different about these things was the C value. Okay? So the C value doesn't impact the axis of symmetry, line of symmetry. Okay, so what that means is we can just focus on the other part there. Alright, so this says constant. So the line of symmetry is the same whether there's a plus C or not. So let's find the average of the x-intercepts. So the x-intercepts are when y equals 0. So if we let y equal 0 and then we factor out an x out of this, that's going to be x times ax plus b. Okay, so that gives us x equals 0 as one of these things. And the other one is going to be ax plus b equals 0, or ax equals negative b, or x equals the opposite of b over a. So if you think about that, one of our x-intercepts is going to be the origin, and the other one is going to be the opposite of b over a. And that axis of symmetry is going to be right in the middle. Okay, so if we find the average of those, that's going to be 0 plus negative b over a, and that is all over 2. We're finding the average of those two things, because the average will be right in the middle, and that's where the axis of symmetry will be. Now, that's a complex fraction, so one way to handle that is just to multiply by a over a. So here, these a's will cancel, and that just gives us the opposite of b, and then down here, we have 2a. Now hopefully, you've heard of that before. So that is the x-coordinate of the vertex, opposite of b over 2a. And then if you want to find the y-coordinate of the vertex, you just plug that in to the function. Now your axis of symmetry is always going to be x equals whatever the x-coordinate of the vertex is. So that's something we need to memorize. The y-intercept is when x equals 0. So in standard form, then that's going to be c. Because if we plug in 0 for x, then y equals c. Unless c equals 0. Well, still, if not unless, y equals 0 could equal 0 also. Okay, so we're still building up some things about parabolas here. Quadratic function is given by this. A and c are negative constants. So what we need to think about is, what does that mean? So a and c are negative. So if a is negative, what does that mean? So if a is negative, that means that the parabola opens down. So any parabolas here that open up would be eliminated. Alright? Now c is also a negative number. Well, we just talked about c is the y-intercept. Because if x equals 0, these are both gone, and we just have it equals c. So if c is negative, that means that the y-intercept is negative. So if I look at these, here the y-intercept is negative, here the y-intercept is 0, and here the y-intercept, oh, that one I don't need to look at that because I already eliminated that one. Down here it looks like that's 0 also. So my choice is A. Alright, so now we're going to get into graphing all the types of parabolas. There's three main types that we're going to talk about. So first of all, this one is in standard form. There's three forms that we'll give them to you in. So standard form, which means y equals ax squared plus bx equals c. Okay, so still, on all of these we should be able to tell whether it opens up or down fairly easily. So that's positive, so it opens up. Okay. Now, vertex is going to be like this. The y-intercept is going to be 0 something. The axis of symmetry is going to be x equals 0. So we can fill all that out automatically. Now, I like to kind of go in the order of what's easiest. So for this, what's easiest for me is if I plug in 0 for x, then the y-intercept is -7. So I have 0, -7 down there. So I want to do that. Okay. Now, the next thing we're going to do is go back and we're going to use this thing that we figured out up here, that the x-core of the vertex is the opposite of b over 2a. Now that only applies if we're in standard form and the a, b, and c are all on the same side. So we're going to have the, so we're looking at the opposite of b over 2a. So b is 6. So I have the opposite of 6 over 2 times a, which is 3. So -6 over +6 is -1. Now I immediately go from there down to here and I say x equals -1. And I actually come over here and I go ahead and I plot that as a dotted line. And because I already have the y-intercept, I can actually reflect that over here also. Now I have 2 points on the parabola. Okay. Now that we know that x is -1, if we plug -1 in here, then we can find the y-coordinates. So that's going to be 3 times -1 squared plus 6 times -1 minus 7. So that's +1, so that's 3 minus 6 minus 7. So that's -13. 3 minus 13. 3 plus -13 is -10. So -10 is down here. Now, a lot of teachers want they tell their students to put the vertex in the middle and then use the symmetry and whatever. Well, yeah, I mean, we can. I'm going to skip down 1 and actually put it right here. So I'm going to put -1, -10. Alright? And then we could put 0, -7. And then this point over here is -2, -7. Okay? Now you maybe one or two of you are saying, hey, Mr. Christian, I thought you said it went 1, 3, 5. It does if a equals 1. If a equals 1, it goes up over 1, up 1, over 1, up 3, over 1, up 5, over 1, up 7. But if it's any other number, you need to multiply that pattern times this number. So I told you go over 1, up 1. Well, it's going to be over 1, up 3, actually, because a is 3. Okay. So there's no fraction, so I can just continue to put some numbers here, and hopefully it makes sense that 1 and 2 probably is better than -3 and -4 to try to plug in here. So if I plug a 1 in here, 1 squared is 1 times 3 is 3, that's 3, plus 6, that's 9, 9 minus 7 is 2. So 1, 2 is right there. And then that's 2 to the right, so I can go to the left. Alright? And if we do one more, 2 squared is 4. 4 times 3 is 12. 2 times 6 is 12. That's 24. Minus 7 is 17. So that's not even on our graph, but that's fine. Okay. Now these narrow ones give me a hard time here a little bit. Let's see. Pretty steep there. And then, oh, see, I got a little wavy over there. Alright. Oh well, that'll have to do. Yeah, it's kind Kind of missed on this side right there. That's okay. All right. So let's this tells us that our vertex is 2, -2, and another point is 5, -11. Find a third point on the graph. So if you think about this, the vertex is at 2, -2. So where would that be? 2, -2. So let's do this. So 2, -2. Let's say that's right here. That's V. Remember then, the axis of symmetry would go through there also. Now we have this other point, 5, -11. Down here, 5, -11. And we have the vertex up here, which also contains the axis of symmetry. So I hope you're kind of piecing that together, what we're going to do with that right now real fast in your brain. Pause. If you need a chance to think about it, pause it. But this point will be on the same side, same distance across the axis of symmetry. So from 2 to 5, that's 3. Now, besides that, it's going to have the same y-coordinate because it just goes straight across. So that y-coordinate is going to be -11. Now, the x-coordinate, let's see. So we had to go 3 to get to here, so we would have to go 3 on this side. So 2 minus 3 is -1. So that's -1, -11. Alright, so let's try to get through this here a little bit more quickly here. So first of all, that is negative. So you can pause, hopefully you can pause this. It's the same kind of thing. Pause it and see if you can do it. So it opens down. Okay. And then the vertex, let's do the y-intercept because that's when x equals 0. So if x equals 0, that's going to be 3. You know this is going to be x equals a number. I know the vertex is going to be an x comma y. So we got all that stuff down. So remember, in standard form, we want to do the opposite of b. So we have the opposite of -1 over 2 times a. So a was -1/2. So 2 times -1/2 is just -1. So we have +1 divided by -1, that's -1. So that's going to be -1, which means this is going to be -1. Now I could have graphed that right away. So 0, 3 would have been up here. Now I have the axis of symmetry, which is also -1. So we can reflect that point across here also. Okay. Now we want to plug -1 in here and see what we get. So we plug -1 in here and square that. That's +1. So that's going to be -1/2. If we plug -1 here, -1/2 is +1 plus 3. So we have -1/2 plus 4. That's 3.5, or 3.5, or 7/2. So that's a little bit awkward, but 3.5 is going to be right about here. Okay. So if we put a couple numbers on here, how about what is that? -2. I don't really want to start -2. I'm going to start at I'm going to start the vertex. So how do you know? It's not that big of a deal because you can keep plotting points until you have something good. So then we had 0, 3. So let's just agree and see. Well, actually, not that excited about that because if I plug a 1 in there, I'm going to get a fraction. So I don't want to do that. So here's where you have some choice. You can pick these numbers. So why don't we pick numbers that are going to work out nicely for us? So what's a good number to choose? Let's choose an even number because we're taking -1/2 times it. So let's try 2, 4, and 6. So if I plug 2 in there, 2 squared is 4. half of 4 is 2, but it's negative, so that's negative 2. I'm already losing track, so it's negative 2. And then plug 2 in here, that's negative 2 plus 3. So 4 plus 3 is negative 1. So 2, negative 1 is right there. And then we can reflect that 1, 2, 3 over here. Okay? And then if we plug in 4, 4 squared is 16. Negative 1/2 times 16 is negative 8. And then minus 4 plus 3. So that's negative 12 plus 3, that's negative 9. So we're going to run out of room here. So 4, negative 9 is down here. And that is 5 across from there. So 1, 2, 3, 4, 5. And we've kind of run out of graph, but since I put it on here, I feel kind of obligated to do that. So 6 squared is 36. Negative half of that is negative 18. And then, so I'm actually going to do this first. That's negative 3, so that's negative 21, which is not even going to show up on our graph, so that's fine. Okay, so try not to rush through that. It's very easy for that to become not a very good looking parabola. Speak to you about this before in the review notes. So this is the one where I wanted to, so I'm going to look at y plus 6 equals, it acts like point slope form. They actually call it vertex form. Some people may have some other names. So if we squared this out, I don't need to be positive, so it opens up. Okay, the y-intercept is when x equals. Now, the nice looks like point slope form of a line, which we've done quite a few times this year. So there's a point. The point is 3, negative 6. Well, guess what? That's the vertex. The point that comes out of the equation from the x and the y is the vertex, which is a symmetry also. So 3, negative 6, 1, 2, 3, 4, 5, 6 is right. So we could graph that. Let's see what the y-intercept is. If we plug in 0, we have 0 minus 3 is negative 3. Negative 3 squared is 9. 9 minus 6 is 3. So 0, 3 is right here, and we can reflect that over. It's very awkward because we have students who tell us that the thing opens up, and we look at their graph, and they have it going down. That's not connecting. That's not thinking about what you have over here and comparing it to this. Think. This says it right. So now we have to choose some more points. I think not that big, but let's see. 1. So if we plug 1 in there, that's going to be 1 minus 3 is negative 2. Negative 2 squared is 4. 4 minus, that's going to be negative 2. And then 2. 2 is negative 1. Negative 1 squared is 1 minus, that's negative 5. And 3 we already have as the vertex. And it's a little awkward now, but 4, that would be 1. That would also be negative 5. Ourselves there. So 1, negative 2 is right here. We can reflect that over. And 3, negative 6 is right here. And so it's following that pattern, 1, 3, 5, because a equals 1. And the next one would be 7. So if you do 7, that should take us right up to the edge there and there. So having those extra points probably help us graph. Okay, so one more. I think that covers most of that. This last one, factored form or intercept form. So each one of these has its unique advantages or disadvantages. So we could multiply this all out, and then we could use that method for all of them. We could multiply this all out and then use that method for all of them. But this is a nice setup right here. First of all, this is negative. If we multiplied all this out, it would be negative 2x squared. So this opens down. Vertex, we should have a vertex. The y-intercept is going to be 0 something. Axis of symmetry is going to be x equals. So maybe one of the easier things to do would just be plug in 0. So if you plug in 0 there, you're going to get 3 times 7 is 21 times that is negative 42. So that's awkward. That's not going to show up on our graph. That's fine. We could change the scale if we wanted to, but we don't want to. Okay. So what now? So what we can do now is realize that our x-intercepts are going to be when y equals 0, and that's going to be when x equals negative 3 and also negative 7. So negative 3, 1, 2, 3, and negative 4, 5, 6, 7. So having those two is pretty nice because obviously they're right across from each other, which means the axis of symmetry would have to go directly in between them. So now we know that the axis of symmetry is, that was 3, 4, 5, is x equals negative 5, which then now this time allows us to go backwards this way, and the vertex is negative 5, the x-coordinate. Now we need to plug that in here, so that's going to be negative 2, and now if we plug negative 5 in there, negative 5 plus 3 is negative 2, and negative 5 plus 7 is positive 2, so that's going to be 8, negative 5, 8. So that will be up here. Okay, so I don't know. Let's just start with negative 7. And negative 6, and then negative 5 was the vertex, and then negative 4, and then negative 3. So we already have these two, those are both 0. Okay. So now let's, now you could just use the pattern. Because a equals 2, instead of going over 1 down 1, it's going to go over 1 down 2. And then I could reflect that over here. So that's going to be 6. Now we could do one more point on here, negative 2, and try that out, but we could also go by the pattern here. So normally 1, 3, 5, multiply that by 2, that's going to be 2, 6, 10. So 10, bring that all the way down to here. Okay, now I'm going kind of fast, but it's because it's kind of a long, so long notes. And see, that one's a little too pointy. That's what I was talking to you about, to try to keep it curved more, especially at the vertex. Curve it. Don't have it come to a sharp point. So those are the 3 different types, and we have them in some of the reviews, and if you need help with that, come by. So last thing is a little question down here. It says that the height and feet above the ground of a soccer ball depends upon the time it's been in flight. Cameron kicks the soccer ball, the height described by this equation. How long is it in the air? Well, this kind of connects to factored form here. If we factor out a 16t, I didn't really give you a chance to think about that. You could pause this right now and connect it to that. That's going to be 5 minus t. Alright? So if you think about it, that means you're going to have 0 and 5. Well, that's the height, and that's at 0 and 5, the height will be 0, which means it's on the ground. So if you think about that, it was at 0, they kicked it in the air, so at 0 seconds, and at 5 seconds, the ball was on the ground, touching the ground. Okay, so how long was the ball in the air? 5 seconds. Well, till it bounced. Is that because it would bounce more than once? So 5 seconds. Does it say seconds? Yeah. Okay, ball reaches its maximum height after how many seconds? Well, if you think about it, the vertex would occur right in between there. So that would be 2.5 or 2.5 seconds, halfway, when it reaches its maximum height. Now, what is the maximum height? You could just plug that in. So that would be, I'm going to plug in 5/2 there, and then it's going to be 5 minus 5/2. So if I multiply this, half of that is 8, that's going to be 40. And if I subtract this, that's going to be 5/2. And 40 over 2 is 20, and 20 times 5 is 100. So that's going to be 100 feet. And it's about that time. Have a good day.